Hi, it's your mentor Pulin sir. Hope you are doing very well. I'm coming back with the next video of polynomial. Let's move on to that. Let's start it. Next very important part of polynomial. Last day we have finished with the definition of zeros and location of zeros in graphical or graph sheets, right? So you can remember those. Now we are going for finding the relation between the zeros and a coefficient, which is very important. And for class 10 we have to confine ourselves up to cubic polynomial, that is the highest we have to deal with. So instead of going to the linear polynomial, I am directly starting with quadratic polynomials. First check what is the standard form. So you can see here, this is the standard form: ax square plus bx plus c, where a is not equal to 0 and ABC are any real numbers. So this is the standard form. Here you have to note only one thing, that when we talk about the polynomial in standard form, always we have to write it in the decreasing order of the power. So in quadratic polynomial the degree is 2. Already we have noted it earlier, so but still once more I am repeating. And then leading coefficient should not be 0. The reason is that if it becomes 0, then the whole x square term will be vanished and it will not be anymore a quadratic polynomial. So that is very clear, I hope. So now let us see what we are getting related to this particular quadratic polynomial. So now we are going to get the relation between the coefficients. These are called coefficients, right? This a is the coefficient of x square, this b is the coefficient of x, and c is the constant term. So now if we have this as a quadratic polynomial and we have two zeros, then what we should get? Alpha plus beta, that is the sum of the zeros, is equal to minus b by a. You remember it like this only, but b is what? It is the coefficient of x. A is what? It is the coefficient of x square. You need not remember so long. Only try to remember that if this is the format, then sum is minus b by a, and in the similar way product of the zeros is c by a, that is constant term divided by the coefficient of x square, right? So we are going for a quick proof of this also, so that if any case you are interested to see, you will be able to get this idea. So now see, if alpha and beta are the zeros, then obviously class 9 you can remember factor theorem, x minus alpha will be a factor of this, as well as x minus beta will be factor of this. So when you multiply the factor, then obviously that should be equal to the given polynomial, because this has been factorized with the help of these two factors. Are you clear about that? But here, as there is a coefficient of x square, so we have to balance it by putting a number. Now at the beginning only we could write this as a, but it is not necessary now at the beginning. So for some constant k, we can write that this polynomial will be equal to these two factors product with a suitable constant. Okay, so now if we go for the next step, what we'll observe, I did not do anything in the left side, only this particular part has been expanded. Then we'll compare. Now you see what is the coefficient of x square, a here, and what will be the coefficient of x square if you multiply k. Similarly, coefficient of x is b. What is the coefficient of x? Alpha plus beta with the negative sign in front. Likewise, we'll be comparing all the three coefficients. Now you compare the first two, because you need to look for a relation between alpha beta and alpha plus beta, right? So because of that, we will have to eliminate k. This is the term, or this is the number we introduce from our side. So what we do, from here you can see k equal to a. So now if I put k equal to a here, what will get? Check. We'll be getting b equal to minus a whole into alpha plus beta, and here I'll be getting c equal to a into alpha plus beta, and that's it. So from here alpha plus beta equal to minus b by a, and alpha beta equal to c by a. That's the final relation what we already have earlier marked. So this you can see, this is a very important result. Important, I am writing it. You have to learn it, because the next problem we are going to take are all dependent on these particular things, right? So next, let's see for the problems. Okay, so here it is the first problem, very important problem, very important problem. Find the zeros of the following quadratic polynomials and examine the relation between zeros and the coefficients. Okay, so I'm doing it very formally for one question. Please note the format, and you will try to use this format for the remaining questions of this grade. Okay, so here what I can write at the beginning, here what is a equal? It is 1. A is the coefficient of x square. What is b equals? Minus 5. And what is c equals? 6. But what is the guarantee that this is small abc? So you must write one statement, very important. It is comparing the given polynomial with whom you are comparing? Standard form. Standard form. So we have compared. Okay, now then we have to find now the zeros, because they are talking about the zeros also. So now we have to use the midterm factorization. Already you all are very clear about this, right? So if you do the midterm factorization, can you split can you remember how midterm factorization was done? Okay, I'll go for a quick explanation for this problem so that you can recall this. For midterm factorization, you have to multiply this value of a and c. So here if you multiply this, I am doing a rough work here. If I multiply 1 and 6, what will I get? 6. Now this 6 you have to break in all possible product of two numbers. So we have broken in two ways, 2 plus 3, 2 into 3 and 1 into 6. Now out of these two, which is going to generate 5? Either by addition or by subtraction. Now the very problematic way is that both are going to give you 5, because 2 plus 3 is also 5, 6 minus 1 is also 5. Now which one is to be taken? Here students may find a problem, so be very alert. I am going to discuss that. When you find such situation, your first target is to see what is the product of a and c. Sign, check the sign. It is plus 6, right? So whenever it will be plus 6, then both these number are to be of the same sign. Then only product will be plus. So in that case, just justify 2 plus 3, 5 is justified, or 6 minus 1 is justified. Very clearly this is justified, because 2 and 3 both are of same sign. Whereas here both are of different sign. You see 6 and then minus 1. If you multiply, minus 6 will come. Am I clear about that? Okay. So I have to choose 2 plus 3. So minus I'll keep here outside, and then this can be written as 2 plus 3. Now As usual, if you break this for completion of your factorization, so you can take this 3 common, then x minus 2, and then what you will get here, then you will be getting this as x minus 2 into x minus 3. So therefore zeros are, see, you can directly write this now. Zeros are, what are the zeros? 2 and 3. 2 and 3, right? So now we have found the zeros. One part of the problem is solved. Now you have to verify, right? Examine or verify the results. What results? Relation between the zeros and the coefficients. So just before this slide, we have got to know what sum of the zeros should be minus b by a. Product of the zeros should be c by a. So one by one we'll verify, right? Now, first of all, sum of zeros we will find. Sum of zeros. What will be sum of zeros? 2 plus 3, that is equal to 5. Also, according to the formula, I should get this whole thing equal to what? Minus b by a. So let me try to identify this, whether it is also giving 5 or not. Minus is there, then b. What is the value of b? We have got this as minus 5. Value of a is 1. So this is coming out to be 5. So what have I find? Sum of zeros is equal to how much? It is minus of b by a. So one part is verified. Now what I should say? I have to think about the product. Product of zeros will be how much? 2 into 3, that is giving you 6. And what is c by a? Value of c is 6 and this is 1. So this is in total 6. Therefore what will I get? Product is equal to c by a. Hence verified. Hence verified. This is what you have to write for this complete solution. Okay, for this complete solution. Am I clear to you? If I am not clear, please repeat this slide, this particular part of the video, and then you see whether you are very clear about the answer or not, right? Okay, now let's move on to the next question. Okay, similar question, only thing is that the values of A, B, C have changed. See, this time I am not going to write in detail all the steps because already I have written in detail the previous answer. So this time I'll do only the mathematical part, right? So straight away A equal to 1, B equal to minus 1 and C equal to minus 6. Then I'm going to factorize this. Now can you tell me, see here also the problem is same, 1 into minus 6. The product will be minus 6. But anyway, that minus 6 will not write in the rough form. 2 into 3 and 1 into 6. Now 2 plus 3, 3 minus 2 is also giving you 1. And then here to only, this is the only option. You cannot get this because this difference is going to give you 5. So here minus we kept here. Then this we can write as 3 minus 2x minus 6, right? So now if you try to break this, what will I get? These things. Okay, very clearly this is 3. Then your factorization is giving you this. So what this time I am going to use alpha for one of the 0. I wrote that zeros are in the previous case, so you can use alpha beta also. So you have got zeros. Sorry, this is minus 2. Zeros you got. Now what is the next part to be verified? Next part is to be verified is alpha plus beta equal to minus b by a. So alpha plus beta you find first. Alpha plus this will give you how much? 1. Now what is minus b by a? minus value of b is minus 1. This is 1. Fine, this is verified, right? So you get alpha plus beta equal to minus b by a. This part is done. Now what is the next part? Alpha beta you have to find. That is 3 times minus 2 giving you minus 6. And what is c by a? Value of c is minus 6. This is 1. Product is this. Then you got alpha beta equal to c by a. Now have you verified these two results? Yes, exactly. So this is the way how now we proceed. See, again I would like to tell you that I haven't written all the steps here, because it is useless to write again the same steps for the same explanation. But as you'll be doing only one problem during exam, you should write complete statement for getting the complete marks. Okay, now move on to the next question. Yes, so same, the heading is same. So here also what we'll do, a equal to 2, b equal to minus 5, c equal to 3. What is the product? 2 into 3, it is 6. So total split up will be what? 1 into 6 and then 2 into 3. Can you now tell me immediately which particular part is to be used? Yes, product is minus. It should be, sum should be 5, but the product is plus. So you should get what? 6 minus 1 or 2 plus 3? Yes, 2 plus 3 is the correct answer, because 6 minus 1 will give you product as minus 6. So this I can write as 2x square. Then this 5 I can write as 2 plus 3x, and then this is 3. Now this is 2x square minus 2x minus 3x, this, and then 2x is taken common, it is minus 1. 3 is taken common, then twice x minus 3, x minus 1. So what are the zeros? You should write a statement. Again I am repeating. From here you will be getting this as 3 by 2, and from the other one, plus 1. So these are the zeros you got, right? These are the zeros you got. Now that you have to verify what? Alpha plus beta equal to minus b by a, because already you have marked this, right? Now you see, at the beginning only, if you want, you can find, you can keep ready these values, right? Because you know that these are to be found out, right? So I am writing this value here only. So this is how much? 5 by 2. And what is c by a? It is 3 by 2, right? So now you find what is alpha plus beta. Alpha plus beta is 3 by 2 plus 1. LCM you take, it will be 5 by 2. Are they matching? Yes, exactly. So that is equal to minus of b by a. So your result is verified. And then this will be 3 by 2 into 1, giving you 3 by 2. And that is exactly c by a. So you have verified here also both the results, that is the relation between the zeros and the coefficients. Okay, move on to the next question. Yes, exactly. So here you see there is some difference. We have to talk about the root over. I am eagerly waiting for this question. Perhaps you also would be waiting for that. What is value of a here? It is 1. B is minus 2 root 3 and c is 9. Fine. What is the product? Process remains the same. It is 1 into 9, 9. So just try to factorize this in all possible ways. 1 into 9, then 3 into 3. Is there any more possibilities? No, not at all. Now which particular part will be considered? Because this time neither their sum nor their differences is going to give you this. Fine. So you have to just observe very carefully. There is no question that we will consider this, because you see there is an involvement of root 3, right? And root 3 can be only generated from 3, and therefore it is eventually neglected. So now just one of the three you break as root 3 into root 3. Another 3 you keep. Now make two pair whose sum or differences will be these things, right? Whose sum or differences will be these things. Now I think I'll not be getting the answer of this. Let's see, because it will not be able to factorize this. Real zeros will not be there. Anyway, let me proceed and I'll show you how it will stick. So here one of the factor you can write as 3, another is 3 root 3, another is root 3. So if you take the difference, what will I get? 2 root 3. So in that way, if you proceed, okay, if you proceed, I can write it like this. But you know where I'm going to stick, or the problem will be a difficult one. The thing is that if I take the difference, then this term will be minus, this will be plus, like this. Product will be what? Minus 9. But I am here getting how much? Plus. So it will not be giving you a real zero. So anyway, I'll modify. Here let me write this as 9, because if it will be plus, you will not get an answer. So let me modify this, okay, so that I can get into the final answer. But you are not allowed to modify this kind of things during the exam by your own, right? So whatever is the question paper, you have to do. If it is wrong, you will be getting marks. Okay, now here you can take x common, so it is x, then 3 root 3, x, 3 root 3, and then here what I can take common? Root 3, x will be left out. Now you see factorization is here only. This whole 9 has been multiplied like this. Out of that, if you take a 3 out, root 3 out, so what will be left out with? It will be 3 root 3. So all that you ultimately get is this particular factorization. So what is the alpha? This. And what is beta? Minus root 3. Okay. So here this was little typical, because root over was involved, and of course while typing I only did a mistake. It should be minus. Now as you did earlier, you keep ready what is the value of minus b by a. Minus b by a will be minus of minus 2 root 3 divided by 1, that is plus 2 root 3, and c by a will be minus 9 by 1, that is minus 9. Now just check what is plus, alpha plus beta. Minus 3 root 3 plus, sorry, this is plus 3 root 3 minus root 3. So what you will be getting, this is 2 root 3. And then okay, this is equal to minus b by a, you can check it. And then what is product? It is 3 root 3 into minus 3, that is minus 9, and again it is c by a. So you are done. Okay, so wait for little time, pause the video and just see complete steps. Try to note it down in your notebook so that you get confidence. Here is the next problem. Okay, this is very simple, right? So here one step you have to write first. You may not write, but you should write this, then you will be clear about the whole thing. So here now if you compare, it is a equal to 1, b equal to 0, c equal to minus 9. So minus b by a, obviously this is 0 means 0, and then c by a will be minus 9. We have kept it ready. Now this so is very easy. You need not go for any midterm factorization. It is a square minus b square. Can you remember that? So that's immediately give you the zeros as alpha equal to 3, beta equal to minus 3. Fine. So if you get this, you find what is alpha plus beta? 0. And this is minus b by a. A very easy question. And this is C, because this is 3 into minus 3 is going to give you what, 9. So this you are going to get verified, right? Get into the next. Yes, here again the constant term is missing, right? Constant 0. That means here if you compare with the standard form, a equal to 1, b equal to minus 3, c equal to 0. So here what is minus b by a giving you? It is 3. What is c by a giving you? 0. Now how will you find the zeros? It's very easy. X you take common, and very immediately 1 0 will be 0 only, and another 0 is 3. That is alpha equal to 0 I consider, beta equal to 3 I consider. So now you find what is alpha plus beta. 3. Is it same as minus b by a? Absolutely. What is alpha beta? 0. So is it same as c by a? Exactly. So these are actually easy type of questions, but even then you should know the complete concept of it. Okay, please halt the video for some time and then see all the questions, whether you have noted correctly or not, and try to solve the question of your exercise 2.1. I have taken very similar problems as the exercise gave you, right? So now let's move on to the next question. Here is the next question. Okay, so this time I am doing the opposite one. In the previous question we have found the zeros, but this time they have given you the zeros and then they are asking you to find a quadratic equation. Now the zeros are given. Find a quadratic polynomial whose zeros are given. Okay, so as we know that this is a quadratic polynomial, I am doing this first question with complete statement as I did earlier, right? I'll explain you everything, so you please follow it. As this is a quadratic polynomial, I can start considering the quadratic polynomial as fx, and I'll use the standard form, right? This be the quadratic polynomial, required quadratic polynomial, right? And alpha equal to 4, beta equal to 3, minus 3 are its zeros. So what do we know about the relation between this and ABC? Alpha plus beta equal to minus b by a, and alpha beta equal to c by a. Put the values. Alpha plus beta will give you how much? 1. That is minus b by a. Alpha into beta, 4 into minus 3. How much it is? Minus 12. That is c by a. So now these two are the relation from where I have to decide the values of ABC. See, we have alternative, that also I'll tell you, but I would prefer you to do by this. Okay. So now for finding the values of A, B and C, we have to compare this equation. You see, in both the equations, A is in the denominator. So whatever is the left part, you try to make in the left side the denominator same, right? Because in your relation, the relation of the letters, A is in the denominator. So what I did, I got 1 by 1 and minus 12 by 1. Now if I compare, what will I get? A equal to 1, then B equal to what? Now you see, minus B equal to 1. Can you compare these two? So what will be B equal? Minus 1. What is C equals? Minus 12. So what will be your quadratic equal polynomial? You write comparing, because here you are writing the complete statement, right? Therefore, one quadratic polynomial, we have written 1. Why? I'll tell you. One quadratic polynomial is ax square, that is 1x square, minus bx, that is, plus bx, that is minus x, and then plus c, that is minus 12. So this is the quadratic polynomial. Okay, why have I told you that this is one? Why didn't I not say that the required quadratic polynomial? I cannot say because this is not only one. Because as I told you, we have compared this, right? Now if some person wants to consider, right, please listen to me. If some person wants to consider that no, I would like to make it 2, and here also I'd like to make it 2. So in that case, my polynomial will be having coefficients 2, minus 24, and then this as, sorry, I made a mistake. This will be 2, and this will be minus 24. That means simply this is the polynomial only multiplied by 2. So in fact, the required polynomial, if you want to write in the general form, it can be written like this, where k is any real number. K is any real number. This is a shortcut, means standard symbolization. I am writing k is a real number. Do not put k equals 0, right? K equals 0. K cannot be 0. Other than that, any real number you can put, and whatever real number you put, all that polynomial will have the same zeros. Now, how you obtain this directly? There is a shortcut rule that we'll discuss, but not right at this moment. So please hold on for some time and overall things you observe, and if you find any kind of problem, you let me know, please. Okay, let's go to the next question. Great. This time we have fractions as the roots, zeros. Okay, so we'll consider this as the quadratic polynomial, right? If you want, you can name it. It is not at all necessary to name it. Okay, so now as you did earlier, you apply. This time alpha plus beta is equal to half minus 3 by 4. That should be equal to minus of b by a. Now if I simplify this, what will I get? 4 here, and then it will be 2 minus 3 minus 1 minus b by a, and then alpha plus beta will be half into minus 3 by 4, giving you minus 3 by 8, that is equal to c by a. Now here the real problem starts. How will you compare? Because a is not same. No issues. You can remember about the equivalent fractions. So just you see which particular denominator you can obtain. See 8, okay. 4 can be made into 8 by what? Multiplying it by 2. So you multiply this. Then what will I get now? If I compare this and this, a equal to 8. What is b? This time minus b equal to minus 2. That means both minus and minus will get cut. Can you compare this? If you have any doubt, please send me detail on my mail or in the views of the video. I'll explain you. This is 2, and then c equal to minus 3. Fine. So if c equal to minus 3, b equal to 2, and a equal to 8, what is the polynomial? One polynomial will be this. Both zeros are as it is given. And if somebody asks you what are all the polynomials, simply you write like this, and k is any real number but other than 0. This is a symbol I am writing from set theory of class 11. Okay, let's move on to the next. Yes, this time again we are having root over symbols. No problem, that's not an issue because the process remains same. Here your polynomial, because you see this time also we are told to find a quadratic polynomial, so I'll not write again those statements, right? Those all Hisapita statement you write when you do the problem. Okay, now alpha plus beta, alpha is this, beta is this, I have considered like this. So this time though I cannot, sorry, okay, here alpha plus beta will be 2 root 3 plus 5. You cannot add them, no issues. Let it be like this, let it be like this. Then what will be the value here? Minus b by a. Fine. Then product, if you find, what is the product of this? 10 root 3, that will be c by a. Now here too it is very easy because you see there is nothing in the denominator, means you can directly consider that as 1. A equal to 1, b equal to 2 root 3 plus 5, and what is the value of c? Now you see these are not the fixed values, as I told you earlier also. So one of the polynomial with this as a zeros are x square plus, very sorry, there will be minus x square, this will be minus 2 root 3 plus 5 whole into x, and then 10 root 3. And if somebody asks you the general polynomial, put a k here, right? That's it, that's it. Next, okay, here again root over with some rational numbers, no problem. Polynomial we consider as ax square plus bx plus c, where a is not equal to 0. Fine. What is the sum of this? Directly we will try to find. It is root 3 minus 1 divided by 2, and this will be equal to b by minus b by a. Product will be how much? Root over 3 by 4 equal to c by a. Now you see which you can make equal, 4 or 2. This can be made, right? So if you try to make it equal to 4, by what you will multiply both? By 2. 2 to the 4, and then 2 root 3. Let me write it like this only. Now comparison you do, a equal to 4, b equal to minus of 2 root 3 minus 1, and what is the value of c? Minus of root 3. Now here we have a freedom, we can adjust this minus just by reversing this order, right? So you can write this as 2 whole into 1 minus root 3. So one of your polynomial having this as 0 is 4x square plus 2 1 minus root 3x, and then minus root 3. Fine. Okay, move on to the next. Find a quadratic polynomial whose zeros are given by this. Same question, this time denominator we have kept purposely different so that you can make a different problems here, you can face different situations. This is the polynomial you have to start with, this is 0, then just their sum, right? Minus 4 by 3 plus minus 3 by 2 should be minus b by a. Then if you try to take the LCM, this will be 6, then this will be minus 8, and then this will be minus 9 minus b by a, so it will be minus 17 by 6 equal to minus b by a. Fine. Now quickly do not write that a equal to 6 and b equal to 17, right, until you complete this, because you do not know whether in this side a equal to 6 or not, right? So you complete alpha plus beta, alpha into beta. This equal to what will you get? This will be C by A. So this 2 will cut it by 2. Minus and minus will be cut, means product will be positive. So this 3 and this 3 will get cut. So this will be 2. Now you see, here we do not get. So now we have to make the denominator 6. By what you will make it 6? Simple. You will multiply 6 here, and then numerator also you have to multiply 6. So what you'll get? A equal to 6, B equal to 17, and C equal to 12. So what is a polynomial? It is 6x square plus 17x plus 12. This is the polynomial. Anyway, as I told you earlier, there is a shortcut which actually we use, particularly I use when we do quadratic equations. But I'll explain it to you also so that you can do the problems in a short way. Okay, so that's the end for today. We'll be doing some more problems on the next video. So till that time, good luck and enjoy. And please do study, do homeworks. Exercise 2.1 now you can complete. Please do complete it. Okay, thank you so much.